Okay, today we are talking about non-uniform circular motion. Here's the questions. A bee flies around a patch of flower in a circular path of radius 4.6 meters. The bee's acceleration at an instant is 1.75 meters per second squared in a direction that makes an angle of 34 degrees to its direction of motion. What is the bee's speed at this instant? And 4 seconds later, assuming that the tangential acceleration of the bee is constant.
So our visualization is of the top-down view of the bee's path. So because this is non-uniform circular motion, we don't draw the acceleration vector pointing directly towards the center of the circle. We draw it as shown in the visual. When we break up the acceleration vector into components, we're breaking up it into the tangential acceleration component and the centripetal acceleration component. The tangential acceleration component vector is perpendicular to the point on the circle where the bee's acceleration is changing. In our justification, we again see that this is non-uniform circular motion because the direction of the acceleration vector does not point towards the center of the circle like centripetal acceleration would. So when we want to solve for the acceleration vector components, we are given in this problem that acceleration tangential is constant, and to solve for the centripetal acceleration component, you use the definition A is equal to v squared over r. We can use kinematics to solve for velocity because acceleration tangential is constant. And finally, we are asked for the speed rather than the velocity, so we have to use the definition of speed, which is that speed is equal to the absolute value of velocity.
Alright, in part A, it's asking for the bee's instantaneous speed. To find this, we can split the acceleration vector into its components, a tan in the y direction and ar in the x direction. Since a and its components create a right triangle, trigonometry can be used to calculate ar. So for the solution, the sine of theta is equal to ar over a. We can rearrange that so that a times sine theta is equal to ar, and in the end you can see that 1.75 meters per second squared times sine of 34 degrees is equal to ar. Ar will be equal to 0.979 meters per second squared. Using the centripetal acceleration equation, ar is equal to v squared over r, we can rearrange the equation so that v is equal to the square root of ar times radius to solve for the velocity of the bee. V is equal to the square root of 0.979 meters per second squared times 4.60 meters. V will be equal to 2.12 meters per second squared, the answer to part A. In part B, it's asking for the bee's speed 4.00 seconds later, assuming that its tangential speed is constant. Because the tangential speed of the bee is constant, we can use the second kinematics equation to find its velocity. But first, we need to solve for a tan using the trigonometry mentioned above. Cosine theta equals a tan over a. We can arrange this to find a tan. A times cosine theta will equal to a tan, so 1.75 meters per second squared times cosine of 34 degrees will equal to a tan. In the end, a tan will equal 1.45 meters per second squared. Finally, we plug a tan into the second kinematics equation to find velocity. So v tan is equal to initial velocity plus a tan times t. 2.12 meters per second plus 1.45 meters per second squared times 4 seconds will equal to 7.92 meters per second.
So in the explanation of wrong answer choices, choice B was incorrect because there was a misunderstanding of which acceleration to use when calculating the speed in the kinematics equation. In order to use the kinematics equation, you have to have a constant acceleration, which we are told is equal to a tan. Therefore, if you use the centripetal acceleration, you would get the incorrect answer of 6.0 meters per second. Choice C is incorrect because the speed at t0 is not 2.58 meters per second. To get this answer, you would have a misunderstanding of the position of theta or use the incorrect trigonometric equations. After 4 seconds, the bee's speed is also incorrect and is not 6.50 meters per second. To get this, you would use the incorrect speed from part A and then use the centripetal acceleration again when calculating the final velocity instead of using the tangential acceleration. Choice D is incorrect for the same reason as stated above in part A, but in part B it is incorrect because you used the speed calculated above, but you used the correct tangential acceleration when calculating final velocity.